Yeah, thanks for the introduction, Christoph. If you watch the old talks, you'll see me get fatter and lose more hair. So I think that's a very classic move for people my age. So I made this talk a couple months ago, and I really liked it. So I thought I would like tweak it a little bit and talk about it because people really get a lot out of it. So I actually started doing Node many years ago, and one of the first things I worked on, and it was back in the Node 0.4 days, I think. So back before we had a major version, was streams. We had streams back then, and I've been through the whole process. I'm part of the streams working group also in Node, and it's been one of the most beneficial learnings from my consulting career because I've fixed so many stream bugs for people over the years. So I thought I would like kind of make myself unemployable by just summing it all up and teaching it all to you. I like to say this is kind of like a depressing talk, but we'll get to it. So it's called Stream Whack-A-Mole. Yeah, I gave it a little introduction. Yeah, I also work on like a lot of peer-to-peer stuff, like Christoph says, and core things, all kind of ties together. So if you don't know Whack-A-Mole, it's this kind of game, where you're bouncing something down, and it keeps coming up, and that's kind of like what it feels like when you work on streams, because you fix something and then it pops up, and yeah. So this is actually a really depressing talk about how you're all gonna go home and be like, none of the stuff we ever wrote with streams would work. Like everything you probably did with streams so far in Node has bugs. I'm pretty sure. So yeah, now's the time to leave. So I thought I'd go through it just to give a little brief history on Node streams. You all know what Node streams are, right? Like you heard about streams before, and you heard about Node. If you ever read a file in Node, or you ever returned an HTTP response that wasn't tiny, you used a stream basically. So the first version of streams came out in Node 0.6. That's like I said, back when I was around. They were very simple. They were what we called do-it-yourself streams. So they didn't do anything. It's kind of like you have to implement everything yourself. So they had this very basic structure where there was this stream module in core. It's been there ever since. You would require it, and you get this object back. And the only thing that object had was a pipe method, and then it was up to the implementer to do everything else. You had to implement like something that emitted data. You had to implement pause logic, resume logic, everything. The only thing that pipe could do was connect streams in a smart way. So basically you had a lot of code that looked like this, where you were given a stream and you had to do something with it. So to read it, you would attach a data listener and get it out, and then if you wanted to pause it, you would try to call pause and hope somebody implemented it, and if they didn't, you would run out of memory and your thing would explode. So I had a lot of old code on GitHub where you just every method is if that method, then do it, and then hope to do the right thing. And it was a fun time. So the cool thing about the system was it was really, really simple because it didn't do anything. But it was simple. You didn't really complain. There was no issues on Node core because there was no stuff there. It was based on something called a push-based stream. So what that means is it's a stream that that gives stuff to you. It has an on-data thing. So you keep throwing stuff at you, and if you didn't want to get more stuff, you would call pause to tell it to back off. It's called a push stream. But it was really, really hard, like I said, because you had to do everything, which meant that nobody got it right. So obviously this led to a lot of discussion on GitHub and on mailing lists. We had mailing lists back then, and finally there was this decision made to make a new version of Streams called Streams 2. Was added in Node 0.10. It was the big thing back then in 0.10, huge. And it had this new interface where somebody, I think, had programmed a lot of Java all of a sudden. They were like, you know what? Abstract classes, add a bunch of those. So abstract classes are basically just these classes that implement all the logic for you, and then you have to implement these hidden methods, and then the abstract class kind of does everything for you. So that was the idea was we take all the code everybody always writes anyway with the emit data and all that stuff and the pause, and we put all that logic in a class, and then people just have to implement an underscore read and call this push method when they have data. So to make it much, much simpler. And then that event, the data event, was kind of complicated. Let's get rid of that and introduce this new event called readable. That would be emitted every time you had data. That was the idea. And again, this is a pattern somebody saw in Java, I think, where unreadable, and then you would call read, and you would get data back. None of that like pushing data to you, and it would be synchronous because it was in an event, and it was really good idea at the time. But it turns out it was really, really complex, and it was really hard to work with because nobody really knew how it worked, and you get all these mistakes. But it was this approach called what I like to call batteries included, where you didn't have to do much as a user. You just had to implement your read methods, and then that was cool. And it was what we call pull-based. So like pull-based means here that you're taking data out of it. You're not getting thrown data to it. So you don't have all that pause logic. It's easier because you can just don't take data out of it until you're ready. That was the idea. So that lasted a little bit, not very long. And then we got streams free, which is basically what we have today. And it was a small iteration on streams 2. Basically, it turns out that everybody wanted to use that on data hook anyway. So there was added this magic code that made the on data hook work together with all this read mechanics, so you could still do the on data, and it would magically start this read loop and emit data for you and all that stuff. That's kind of where we are today. So the thing about streams is that they're still evolving in Node. All the APIs are still evolving. And every time we work with streams in core, we get a ton of issues. It's probably the most advanced GitHub filter I had, because it's I probably get 20 or 40 emails every day if I don't, pause it, because people just open issues, and we're 4 people. And every time we get a PR that's I fixed the bug. And every time we gotta be cool. Because then we know we merge it, and somebody's gonna be fuck you, you broke my shit. And it's literally like adding a new variable. It's gonna break somebody because they extend that class and they use that variable. Or, we changed the timing of a method a little bit, and I think we broke gulp that way for a long time. It's really, really frustrating and fun. And that's because it's if you think about Node core and what you get from Node core, the APIs you get from Node core are actually very simple. Most of them is read file, passed in a string, and you get a buffer back. Or gzip, pass in a buffer, you get a smaller buffer back. Or HTTP, run a server. The only thing you get back from Node core is not just a buffer or a string. Most of the time it's these stream thing, because these stream things are you get an object back, it has 1,000 methods on it, and a bunch of documentation. It's very complex. So I thought I'd kind of illustrate why this is a problem, and just make some code and that's really problematic, and then show it to you, and then see if you can spot why it's problematic. Yeah.
So what's the take on using asynchronous iteration over streams?
Maybe we can take that at the end, but that's a really good point. That's kind of the future, I think, also. So I don't know if you ever use streams, but this is a classic snippet I see a lot from streams, where somebody's making, requiring streams. He does a lot in the wild. You can see here I'm old school, I still use the vars sometimes. Not always the cons, but let's leave that for a later discussion. And then you make a readable stream, and then imagine you're doing something with it, and then at some point you're actually I don't need the stream anymore, I'm gonna destroy it. Do anybody know what the problem is with code like this in the wild? Well, the problem here is that if you run on Node, you don't know which node you're running on. So if you write a module that does this, if you run this on 6, 6 is agent now, but this fails. It's just gonna be method not defined. Undefined is not a function. If you run this in Node 8, it's going to trigger what internally is called push null, which then will pretend that the stream actually is not ending, but it's gracefully ending. So that's going to do something different to your code. And if you run this in Node 10, the stream is going to emit a close event. So now, depending on the system you're getting, you get this really weird behavior sometimes. So that's where all the bugs come from, where you're we're testing, it works fine, and then somebody runs your code and it's yeah, it broke my shit.
Can you explain what you mean by other node instances?
So, for example, if you have a module where you do something with streams like this, you don't know what streams you're getting, because streams vary per node runtime. You don't control the runtime, right? Because people have all different kinds of runtimes. And you also don't know what it's going to give you in the future. So it's just very complex, and we see a lot of bugs with this. So there was that was a problem. So the idea was, let's make a packet that contains all the stream stuff on npm, but like have it be an official packet by the maintainers. And then there we can have all the stream stuff, but then we can kind of version it. So instead of requiring stream, you can require readable stream. And there was this amazing, this is what I love about streams because it's full of stuff like this, why is it called readable stream? It's because, we thought it was only going to be readable streams back in the day, but it also has writable streams in there now, it has all the streams. So why didn't we change this? Like, legacy. So, deal with it. So basically, if you require a readable stream, you can version that, you can put it in your package JSON, and then you know what you're going to get. So then like, if it has destroy, it's going to behave the same way all the time. So if you're writing modules, I write a lot of modules, and you're using streams, and you want to use streams, you should probably always just require this userland one, because then you know what you're going to get. It's not going to change underneath below you. It's not going to lead to crazy issues. So that's like my first little tip. Yeah, cool. All right, this is probably the bug I see the most. So I see a lot of code, especially back in the day in HTTP servers, where people would like make a file stream, and at some point in the code they'll be like, I need to find out when the stream has ended, right? Because maybe I'm allocating some resources, and when the stream ends, I want to unallocate those resources. So they write code like this, where they would, make a stream and then listen on end for wait for it. So does anybody know what the problem here is? So basically, this code will never run. When you run this, nothing happens because nowhere in this code are we draining the stream. So when you just make a stream, it's not going to do anything. It's not going to end ever. You can wait a million years, it's not going to end. This is probably the number one issue I get on GitHub, people being like, I found a bug in your stuff. It's like, it didn't emit end. I'm like, it's not a bug. And we go over this all the time. But it's because it's just very, very confusing. So that causes a memory leak. And I've seen this a lot in work I've done with HTTP servers, where people just have this kind of memory leak all the time because they forget to drain your stream. They might be like, making the stream and then checking something if the user is logged in, and then if not, they return. That's a memory leak. So always drain your stream. So what does draining your stream mean? It means you have to do something that reads the data. So that can, for example, be you can call resume on a stream. That'll drain the data. And then when it's done, drained, like all the data has been written out, you get an end event. So then it works. You can also do stuff like this, where you do that whole readable dance, where every time there's a readable event, you actually read the data out. They'll drain it also. Then you're reading out the data. Or if you're piping it somewhere, it'll drain the data. So always nice to have a lot of different ways to do the same thing, right? Or this is the favorite one. If you attach a data handler, that also drains the data, because a data handler, like an event listener on streams, is not an event listener. It's like this magic where it goes in and starts draining your stream for you. So even though events normally just have no side effects, in streams they have tons of side effects. So be aware of that. Yeah, like I said, it's magic. So basically what OnData does is like, if you first attach a data listener, it'll basically implicitly in the code call resume and start emitting that data. But if you call pause first, it won't do anything. So it's very stateful. It's just very hard to figure out. So don't really rely on this kind of behavior doing anything. You should always call resume if you ask me, or pause if you're doing anything with that. Cool, yeah, this is a good one also. So there's this event in streams that's called end, but it doesn't mean end. What does that mean? On end in streams means that it's a readable stream. The stream is giving data to you, and it has succeeded. There's no errors, and it's done. The buffer has been flushed. That's what end means in streams. So yeah, this is another example of code I see a lot that help people fix a lot. So this.
In what way is it not the end then?
So I can tell you this right now. So if you have code like this, where you're like, where you're like allocating something, or like, here's like, let's say you have a program where you're serving files over streams, and you want to count how many streams do you have at any given time, right? It would look something like this, where you set a variable, you increment it when you get a request, you make a stream, and then when it ends, you want to decrement that variable, and you expect this over time. If there's no users, the streams number of active streams will go to 0, right? The problem here is that end doesn't mean end in the way we mean it in the English language. It means that the stream has succeeded successfully, there was no errors, and the buffer is done. So it might never fire. If there's an error, end might not fire. There's no guarantees that end will ever fire. It's only going to guarantee work in all the good cases, which is probably the ones you're testing. So it looks well in the test. Then you run it in practice, and you're like, oh, that's some bug, and I don't know what it is, so I'll restart my server. So it's actually not that hard. There's just only 4 events you need to worry about. It's all kind of the same. So a stream in Node can end with either a close event, an error event, a finish event, and or an end event, or like a combination of the 4, depending on the matrix of the Node versions you're running. So it's incredibly complicated. And I love the fact that they all kind of sounded like the same thing. I'm not a native speaker in English, but I would say that all those things are kind of like, at least trying to convey the same thing. So you just write code like this, where you hook up to all of them, and then you check which one. If one of them fires, if it fires once, then you decrement your variable, and if not, then you wait. That works in almost all cases.
So is there no event or a planned event that is called in all these instances, some kind of like a finally event?
No, so that's kind of what the idea is. The close event is, and that's kind of what where streams are moving in Node. That's close is like, because close is the most dominant one of those words, I guess. And but unfortunately, all streams still emit close. Like if you're running Node 8, they still emit them, but then they emit them a little bit earlier than the other ones. But I got a solution coming, so don't be too depressed yet. Yeah, so if you were, this is actually pretty funny. So like the finish event doesn't mean that it's from Finland. It means that it's writable, and the writable side has succeeded. Every write has been flushed, and it's done. I guess we need another word to sound like end, so we are like let's finish. And the best part is that's triggered by calling stream.end. So if you call the end method, it doesn't trigger an end event when it's done. It triggers a finish event. So basically, to trigger an end event, you got to push a null. Like that's how you say it's done. That triggers an end on the other side. And if you end it, it triggers a finish. I found this. It was very. When I first, this is. I don't. It's just very confusing. So why do we do anything that's weird in programming? It's because of backwards compat. Because, like I said, this is where people come in and like, I fixed this for you, and we're like, yeah, you broke literally like 50,000 modules. It's surprising how little code we can change. So to work around this, back in the day, I wrote this module called end of stream. That is the module I've written that has probably the most downloads. It has like 20s of millions of downloads every month for a week, or it's like just insane. And it's also the number 1 module I tell people about that they always implement themselves, and I'm like, don't do it. They're like, no, I'm just gonna, I'm just like, don't do it. So it's like a module that contains probably 200 or 300 lines of code just to figure out how to do this in the most, safe way. And what it does is it gives you a callback. It's back when we did callbacks, where you can pass a stream to it, and it'll call back when it's done. So now instead of writing all those event emitters, you can just do this, and this works in 99.9999% of cases. So that's what you should just do this. And also good that we added it to Node Core. We called it finished. I don't know why we called it finished, but it's kind of nice. So if you use Node Core, I think it's in Node 10, which is probably what we're all using now. Then you can just require a stream and get the finish method, and that's this kind of thing. So that's what you should do now if you're doing anything with streams. You want to know when it's done. Use the finish thing. Oh yeah, I forgot I had this one. Yeah, so it has my module has 1.6 million dependents on GitHub, and it has 100 stars, which is pretty fun. It's one of those things where, like, people sometimes talk about, like, why should we care about, funding? I'm like, yeah, fuck you. Anyways, I got more. So this one is like one that ties everything together. So this used to be the #1 example on the Node website. When you go into Node, you're like, Node is cool, and you had those big files, you can just pipe them out. You can write an HTTP server in 3 lines of code. It looks like this. So this thing has a massive bug. I don't know if you can spot it. You probably can't because you haven't read all the stream code I have. So this has a massive memory leak. So basically, if there's any kind of error reading that file, or the file doesn't exist, or anything bad with the file system, this will memory leak. That's because the pipe method in Node doesn't do any kind of error handling at all. And it's been true for many years, and I've been telling people for many years. I don't know if you know, but it always surprises me still how many people don't know this. But pipe is it doesn't do any error handling. It only works for the good cases. So how do you work around this? Well, you just import the finish module and do all this little dance where you're like, if either of the streams fail, you make sure to destroy the other one. So this, yeah, and just never use pipe. That's the solution. Use this module called pump instead. What pump does is it basically does this. It's just this in a module. This gets you can do this yourself if you wanted to, but imagine if you're piping had a gzip stream in between, it gets very dense really fast. So if you use the pump module, it does that for you. No memory leaks. So does error handling. Gives you a little callback at the end that you can promisify. Again, this is before we did promises. When the pipeline here is done, it does all the dance with shutting down the streams if there's an error. That whole thing, super nice. Again, so nice that we got it added to Node Core. There's actually a pump method in Core also, so that was taken from way back in the day. So it's called pipeline. It's also a really cool sounding name. So if you require a pipeline, then you can do these stream dances yourself without any errors and any memory leaks. So that's really nice.
So that's an alternative to pump?
It is. It's just a pump code. We put it in Node Core.
All right.
Yeah.
So then if you use that, you don't need pump?
Yeah, basically.
Since which version?
It's also since one of the later versions of Node 10. So anything more than Node 10 is...
in a recent readable stream, right?
Yeah, or in any readable stream. Or you can use pump if you're really... I just still use pump because I'm old and grumpy. But this is exactly... I poured this code in there, just exactly the same. Yeah, also just to give you an idea, this has 1.4 million dependents out there. This is also a module, I feel for people. I get so many issues on this. People are like, I found a bug. I'm like, no. And it's never, because it's just streams being crazy. But yeah, it's fun. Fun times. I was just trying to remember here. Oh yeah, okay. Oh yeah. So if you want to write your own streams, I don't know if you've ever written your own streams. I've written a lot of my own streams. This is how you do it. This is like that abstract class stuff where you make a writable stream, and then you gotta override the _write, which is the method the stream calls on you when it actually wants you to write data, and has this 3 arguments: data, encoding, and CB. Nobody knows what encoding means because it's never used anywhere, but it's in there. We deal with it. So let's say you have code that looks like this. This is also something. I fixed so many bugs. I fixed so many security bugs with this, where people had massive security holes because of this pattern. But anyways, we'll get to that. So, they'll do stuff like, oh, I'm getting data in. I have this method that checks if probably the first message is a handshake or something like that on the stream, where you send your credentials or whatever. Then I'm gonna emit that because I'm nice. And then when I'm done, I'm gonna take that data, slice that data away. That was the handshake, and then call push in the method here, get the rest of the data out, for example, something like that. You can imagine something like that, right? So this has a really huge bug because when you emit events in Node, you're giving your flow control away. You're telling somebody else, like, you can run a function now, right? Anybody who listens on Handshake can run a function. So why is that a problem? Well, the stream is a massive state machine. So they can do all kinds of stuff in this Handshake. So for example, they could be like, the credentials are wrong, I'm going to destroy the stream, and call destroying the stream. And then that happens, but then your code comes back to you because we're writing JavaScript and synchronous. And then now the stream is destroyed, but we're still doing stuff with the stream on the next line. And then now this is going to have like consequences, right? Because the stream might be destroying or destroyed, and we're pushing data to it. And it's probably going to throw an error, so now we crash the process or do something else. That's what I mean by security errors. Everything can have changed underneath us. So you gotta sprinkle these in a lot. Like every time you do something that has any kind of side effects, you gotta check all your conditions again. So like every time you emit something, you gotta check next line, were we destroyed? If so, stop doing what we're doing. Otherwise, we're gonna have a bad time. So yeah, the Buus code, hell yeah. There's actually, side note, is a pattern I've seen a lot doing code reviews and promises also when you do the big, async await chains and you emit an event and people then forget that side effects can happen and then they happily continue after. Again, if you have a security hole, that's probably where it is. Yeah, so like I said, every time you do any kind of emits, check your public state. Yeah, like I said, it usually means checking that you're destroyed. All right, everybody feeling good? That's basically it. That's all you have to worry about. Not too bad. Takeaway is never use streams. Always use modules. When you think you don't use the modules, then just use the module. It's a dependency or it's like a core thing, but you're not going to have security holes. You're not going to have bugs. It's impossible to do it yourself. I would stand by that every day. Yeah, also, this is like really soggy advice. The only way to understand it is really to read the source, because there's massive side effects for everything. And yeah, it's soggy advice, but read the stream source, then you'll have a better idea. It's a lot of code, it's like thousands of lines, but you're probably depending on this every day if you're doing anything with HTTP servers. So yeah. So the future. This is how we're fixing all this next week. No, it's gonna stay bad. So it's like, is it gonna be streams 4, streams 5, stream 6? So I was like, it's gonna be streams X, kind of like the iPhone 6 was like, the one where they stopped caring about numbers. But now they went back to numbers again with the 11, so I don't know if this is true. So I wrote this module, I got very frustrated, and I wrote this module called stream X, kind of like the best versions of streams, that just takes away all the backwards compat, which I can do because it's a module, so I can be like, whatever, and just makes very strict guarantees about everything, but containing the same streams interface, so it works with all the Node stuff. So if you're doing anything with streams, like as in implementing them, then this is probably something it's worth looking at. So it does stuff like, error handling the pipes, proper lifecycle. What I mean by that is like that you can actually know when a stream is being opened. You don't know that now, and when it's being destroyed, and that you're not going to have a write during a destroy and all this kind of stuff, which you have to worry about with normal streams. Backwards compat, meaning backwards compat in the module itself is not going to break because it's so simple, and it's like that it works with Node and tons of other stuff. So this is how you would write a simple file stream with a stream X stream. So you have this very nice open method that's guaranteed to run before anything else, where you could be like, I'm going to open a file descriptor. Then you can have, I removed that encoding argument that nobody knew about. So that was kind of nice. You can write data, and then it gives you this little destroy hook where you can actually, stop doing stuff. And that's always guaranteed. And it's always guaranteed to emit the close event, that is the last event, stuff like that. That was my talk. Thank you.